In this video tutorial, we'll introduce Diffblue Cover CLI. If you had a chance to run Diffblue Cover as a plugin to IntelliTray, now this is the moment to explore the numerous advantages of running the same product in the CLI mode. Let's see first where Diffblue Cover fits in your Java ecosystem. Diffblue Cover is an AI product which automatically writes unit test code without human interaction, and it does it by analyzing the bytecode of your project. Developers typically aim for high coverage, as this will ensure that most of the codebase is appropriately tested. But coverage is not the only benefit coming from Diffblue Cover. While writing tests, Diffblue Cover efficiently reveals observability issues such as private access modifiers and untestable error-prone areas of your codebase, such as methods which handle uninitialized fields. Using Diffblue Cover starts with having access to the source code. A build tool such as Maven or Gradle is then used to compile the source code into bytecode. For each Java module, Diffblue Cover runs the bytecode in a sandbox in order to record all method calls. This also reveals observability and testability issues. For the testable part of the codebase, Diffblue Cover can then proceed to write unit tests. The test code is validated by running it versus the source code. Eventually, the user is left with a suite of unit tests which pass and accurately map the source code. Explained briefly, the developer workflow can be something like this. First, the source code is written, or this might be existing, probably legacy code. However, the source code needs to follow the Java hierarchical structure, that is, to be organized in modules, packages, classes, and methods. With a simple command at your terminal, Diffblue Cover will write unit tests which generally reflect the source code logic, be it good or bad. Unit tests will be written for each testable method, including constructors, whenever possible. Eventually, there will be a mapping between the source code and the test code. Here are the most important reasons for using Diffblue Cover CLI. It writes unit tests at scale without anyone needing to control the process. It can be executed from any terminal installed on your operating system, and you may find this much easier and more efficient than clicking in an IDE. Calling Diffblue Cover can be part of a script and thus be integrated in a wider scheme. For example, it can be integrated in a CI pipeline using Jenkins and GitHub. It does not need an IDE, but your IDE console can be used as well. It comes with many sophisticated runtime options which can be passed at the command line. Some of them will be presented in this video tutorial. It integrates with Cover Reports, which is another Diffblue product used to assess your unit test coverage in detail. And finally, it can be used with git diff operations such that for projects in development, it writes unit test code only for the modified and affected classes without the user having to specify them. We'll start by reviewing the installation process, and as you will see, this is quite easy. We then outline the project setup, that is, we show how to make sure that it contains relevant dependencies. After this, we'll be ready to see Diffblue Cover in action on a sample project, and we'll start with a single module example. We'll then learn how to run Diffblue Cover on projects with more Java modules, and briefly outline the logging capabilities of Diffblue Cover CLI. As the command line options pile up, we need to introduce the command chaining concept. We'll introduce then the patch-only mode as a convenient way to get Diffblue Cover running only for new and modified Java classes. Finally, with the unit test classes in place, we're prepared to assess the coverage by producing Jacoco coverage reports. The installation process is straightforward. First, the product needs to be obtained, and this comes as a zip archive. A new version of Diffblue Cover is released every 2 weeks, and the version number is listed as year, month, and release number. The zip archive contains several Java archives and should be extracted to a permanent directory whose location needs to be added to the path of your operating system. It is then easy to upgrade the Diffblue Cover CLI version by simply replacing the contents of this permanent directory. Then open a terminal and type dcover --help. If Diffblue Cover is found, it should print a list of available commands. Among them, activate can be used with a key provided by Diffblue in order to license the product. Another important command is create, which is used to start Diffblue Cover CLI in test writing mode, and yet another one is coverage reports, used to generate Jacoco reports. To make use of Diffblue Cover, we need to add a minimum set of dependencies. This is normally done through the POM.xml file for Maven, as for example here we can see JUnit 5 and Mockito. JUnit is mandatory because Diffblue Cover cannot write unit tests without it, while Mockito is recommended because Diffblue Cover can use the Mockito framework in order to mock method inputs. The Maven Surefire plugin is also needed in order to validate Diffblue tests by running them. There are the same requirements when using Gradle, and this is an example of the build Gradle file. Again, we see JUnit 5, Mockito, and the test closure. Using the bytecode, Diffblue Cover effectively maps the Java source code into unit test code, and it does so going through several stages. First, there is the environment check. This includes operations such as checking the Java version, detecting the build tool in use, identifying the class path, and making sure that all required dependencies such as JUnit or, depending on the case, for example Spring, are available. At this stage, the user might get errors or warnings if, for example, a dependency is used at an unsupported version. Also at this stage, Diffblue Cover will check if a dummy unit test can be executed and a warning will be otherwise shown. The next stage is identifying all testable methods, and this is done using the bytecode. At the console, this stage appears as filtering classes and methods because not all methods are directly testable. For example, private methods will not be detected. Now, having a list of callable methods, Diffblue Cover will proceed with creating unit tests. This is an iterative process in which for each callable method, many test candidates are proposed. Following a reinforcement learning algorithm, a single unit test method is kept. That method maximizes the source code coverage. This stage finishes when all methods are either fully or partially tested, with the latter case being clearly marked by reason codes. Eventually, all Diffblue unit tests go through a validation stage. The build tool is used to execute them one by one, and Diffblue Cover will eliminate those which possibly fail. This is an important safety operation which ensures that all unit tests written by Diffblue Cover pass. Here we have a single module Java project built with Gradle. It is made of 3 packages which contain a few classes, an enum, and a record. Because the project was built, the bytecode is available, and therefore we can run Diffblue Cover. The simplest way to do it is to use the command dcover create. This will write unit tests for each class across all packages of the project. As we can see, the test folder now contains 3 packages, and the unit test classes map the source test classes. With development work in mind, we can consider the existing source code and its unit test suite as the project baseline. It is also possible to get unit tests only for a class by using its fully qualified name. For example, let's ask Diffblue Cover to write unit tests for the class branches, which belongs to the first package in our project named extra. We will use the command Cover create followed by the fully qualified name of the class. This class contains two instance string fields, which are private, and a setter method for each. We are curious if all branches in the method getItCovered are considered by Diffblue Cover. Indeed, having the setters helps because, as shown in this test class, Diffblue Cover uses them to produce inputs which completely exercise the method under test along all of its branches. We also get a test for the constructor. We'll go now to a deeper level and ask Diffblue Cover to write unit tests only for a method defined in one of our classes. Let's choose the season enum with this occasion. It is an enum with an implicitly private constructor and three methods: getValue, getOrder, and getItem. We focus on this last method, which takes a string, builds an optional, and returns either an item from the enum itself or null. Again, we want to check if Diffblue Cover can deal with both of these branches. We typed the command dcover create followed by the fully qualified name of the method. Indeed, except getItem, all other methods were ignored. Diffblue Cover wrote two assertions for getItem. The first one confirms that the method will return null if a random string is provided as argument. The second one asserts that the method will return an enum item if the string argument happens to match its value. Let's now use Diffblue Cover on a multi-module project. Here we have two Java modules, app and common. This project is designed such that the app module depends on the common module. This can be seen from the two module.info Java files. Common exports the package org.utils, while app requires that package. To make the crosstalk possible, this link is also declared in the build Gradle file defined in the app module. Let's attempt to run Diffblue Cover using the command dcover create from the root of this project. We are prompted with an environment code, namely E005, and a recommendation to use the option working directory in order to specify one of our modules. Let's now use the working directory option to write unit tests for the app module. We can see that both packages are tested. Now, using the working directory option and what we learned in the previous section, we can target, for example, only two classes in the second package. To To do so, we will add at the command line the fully qualified name of the classes separated by a space. We can now see that the work feature package contains only 2 test classes, while in the source package there are 2 classes and 1 record. Diffblue Cover offers rich logging information, and in order to get an idea of what this means, let's write unit tests for the work utils package of the common module. It contains an interface I and 2 classes A and C. The interface comes with 2 fields and 3 methods, one of which is overridden by the class A. The other class C is isolated and contains a private static method. Let's see how Diffblue Cover handles this package. Very brief information can be seen at the console. Here we have the environment check, filtering, writing tests, and eventually validation. A summary is shown at the end, and we can see that 3 tests were created for a total of 5 callable methods. While running, Diffblue Cover generates a directory named .diffblue at the root of the module being tested. Inside it, there will be 2 log files, a user log file and a support log file. The former one offers an overview of how Diffblue Cover went through all of its stages and what was the outcome, while the latter one is more verbose, contains more details, and should be used when contacting Diffblue support. Let's look inside the support log file and identify key elements. Here is the command typed at the terminal. Here is the environment check summary. Diffblue Cover writes unit tests for one method at a time, and the log file refers to its signature using the bytecode syntax. For example, this is the default constructor of class A. The R002 code is shown, and this means that JUnit assertions cannot be formed because there are no fields. Indeed, back to the A class, we see that the class contains only a method override, but there isn't an instance field which would allow the default constructor to initialize it. What about the function method override? Is that tested? Indeed, in the log file, we can see that the bytecode syntax tells us that a method which takes a double and returns a double is tested, and it is done through one assertion. Eventually, there is a summary for the performance of Diffblue Cover, and this is very useful because it guides the developer to refactor the code in order to maximize unit test coverage. Recent codes such as R002 or testability codes such as T005 are explained in the online Diffblue documentation. Diffblue Cover comes with many command line options which fall beyond the scope of this tutorial, but one thing is obvious: the command line becomes too long as the user plugs in more options. For this reason, we'll introduce the command line chaining concept. Here we expanded the 2 packages of the common module. Let's say we want to test the interface I from the package org.utils and the class B from the package org.source. At the terminal, we'll normally type dcover create followed by the working directory option and a list of fully qualified class names. While that will work fine, there is yet another way. we need to add an arbitrarily named text file at the root of the project. Let's name it config.txt. Inside it, we'll add options which we normally type at the terminal after the cover create. So let's paste the working directory option and list all the classes that we want to test. Back at the terminal, we now only need to type the cover create followed by the name of the text file. Indeed, as expected, calling Diffblue Cover from the root of the project, we tested only the interface I of the org utils package and the class B of the org source package. The interface was tested in two ways. The static getHeight method was tested calling the method directly on I, while the default getTemperature method was tested calling an instance of a class which implements I. It is reasonable to assume that having already a baseline, that is a source code base, and a suite of unit tests associated with it, a user will not want Diffblue Cover to rewrite all existing unit tests on every run. As we have seen, there is always the option to target various packages and classes, but for large-scale projects this is not an option because the user would need to keep track of the changes. The patch-only mode refers to the remarkable capability of Diffblue Cover to write unit tests only for new, modified, and affected code. This is where Diffblue Cover interacts with Git patch files which contain code differences. Let's consider this baseline. That is, based on the source code shown on the left, Diffblue Cover has already written the unit test code shown on the right. To use Diffblue Cover in patch-only mode, the code must be committed first. Then some changes are made with the difference being saved in a patch file, and finally Diffblue Cover can be started using the patch-only option pointing at the patch file. In patch-only mode, Diffblue Cover uses the patch file provided only as a seed, more exactly to determine where to start the code analysis from. If we were to change class A, which is the base of an inheritance tree, is/or relationship, the patch file will contain only modifications made to this class, but Diffblue Cover will use it as a seed to track all classes which extend it or implement it if A were an interface, and rewrite unit tests for all of them. Similarly, if class N is modified and there are classes which aggregate it as a relationship such as P, although the patch file will contain only modifications made to class N, Diffblue Cover will track all classes which aggregate it and rewrite unit tests for all of them. On the contrary, if modifications are made to an isolated class such as Y, only the unit test class associated with it will be rewritten. Thus, the patch-only mode becomes a time-saving option when the project is in development, that is, after the very first run of Diffblue Cover. We have shown how Diffblue Cover can be used to write unit tests for an entire module, such as common, shown here. And we notice that the .diffblue folder is generated. Let's expand it. We have the log folder, but also the reports folder. There is a unique JSON file written by Diffblue Cover and updated with every run. This file contains a summary of the overall performance of Diffblue Cover. In fact, it describes the stability of the codebase and contains, for example, lists of reason and testability codes for each Java class. Having the unit tests written by Diffblue Cover is of course an important achievement, but how can we assess the code-based coverage? The report.json file is part of the answer, but we also need some output from the Jacoco plugin. When using Maven, the Jacoco plugin needs to be added within the build fragments. Alternatively, for Gradle, the Jacoco plugin needs to be applied in the plugin's closure. Running this plugin will allow us to obtain coverage reports, and they will be referring to lines of code coverage. More exactly, we can get a percentage figure of how many of the source code lines are tested. Diffblue Cover has a command line option for triggering the Jacoco plugin. From the multi-module project root, we need to type dcover coverage reports followed by the usual working directory option. Note here that the words dcover and coverage reports must appear next to each other. We notice that two XML files appeared. They are our coverage reports for Diffblue unit tests and for manual unit tests. Let's open them. The XML coverage reports contain fragments which refer to packages, classes, and methods. Let's look, for example, in the package workutils class I, which is our interface I, and method getTemperature. Jacoco tells us that this method contains 5 low-level instructions. We didn't have any manual unit test for this method, and therefore these instructions are not manually covered. However, as shown in the Diffblue test Jacoco report, all these instructions are covered. Furthermore, we see that this method contains only one line of code and is not covered manually. Indeed, the body of this method contains only one line. Contrary, our Diffblue unit test covered this line. Together with the report.json file, these two XML coverage files are used by Cover Reports, another Diffblue product used to assess unit test coverage in details. In this tutorial, we learned how to install and start using Diffblue Cover in the CLI mode. We have seen how to use various command line options for single and multi-module projects. We explored a few Diffblue unit test classes. We understood how to use the patch-only mode and why it is important. We have used Diffblue Cover CLI to generate Jacoco coverage reports. There are more command line options to explore in other tutorials, as for example, mocking with Mockito and disabling the sandbox policy, which would allow Diffblue Cover to write unit tests using potentially unsafe operations such as handling files and sockets. This was a brief introduction to Diffblue Cover CLI. For more details, visit diffblue.com.